Yeah, you figure I'll do a comment video and such. Might as well. The first comment is okay. According to Newton, according to you, Newton did all the experiments and very careful in what he said. Yeah, in 99% of the cases, he didn't say anything that was wrong. But obviously, he didn't. I'm not really saying he didn't say anything that was inarticulate or confusing because, yeah, he did. I guess I should once again copy and paste the quotes concerning his pendulum experiments that you are completely ignoring. I'm not ignoring them. I'm saying I doubt it. Okay, and I have reasons to doubt it. And I've explained the reasons. Okay. And so he quotes, by a congress of collision of bodies, the quantity of motion collected from the sum of the motions directed the same way or from the difference of those motions that were directed toward contrary ways was never changed. Well, okay, so I'll give you an example. All right. I already said one example. You're effectively arguing that Newton increased the quantity of motion in a direction and in the system and didn't notice. All kinds of explosions prove energy left does not undo energy right. A lever, for example. You're claiming you can have an elastic car crash where 200 momentums go in and only 100 come out. Now, how is that conservation of momentum? So obviously, yes, car crashes don't work that way. You can't have a car crash with 100 in and 100 in and have nothing out. Yeah, no, that can't happen. The sum of the difference is not a correct answer to the collision problem. All right, so and another example I just thought of, so I thought I'd throw it in, do the drawing and such. So, gotta get rid of this. Okay, this one probably I just can do in one color. All right, so let's just say you had pool balls, and instead of putting them in a normal triangle, it'll still work in the triangle, but let's just do it this way instead. And you have a cue ball and you launch it with a MV, and the idea is that everything that leaves will be, when you add it all up, it'll add up to the MV. Now the problem with your argument is some of this stuff is going to be going in different directions, especially like these two are going in different directions. So do I subtract those, and do I subtract these two, and do I subtract these two? Then all of a sudden I didn't conserve the momentum. Momentum won't be unchanged. I had 100 going in and I have 2 coming out. So I'm just saying that experiment right there proves, I think, that it's impossible to play this game that motion this way undoes motion that way and you subtract it because it's all real motion. The motion must be fueled. You could think of it as fire. It's all fire. You have a certain amount of fire. You can't make free fire. You can only use the fire you put in. You can't have extra fire. You can't have unfire or negative fire. All right. So I think that's a pretty decisive argument, right? I mean, it's inevitable that the pressure will go through this thing and there will be balls going in opposite directions. Like I said, even if I do a square or a triangle, it doesn't matter. You know there's going to be balls going this way and this way. By your math, I should subtract those energies and pretend they canceled. They're not part of the equation. Well, if I do that, then when I add up the MV, the rest of the balls, it's not going to add up to what I put in. So it won't remain the same. So Newton will be proven wrong by your definition. This simple experiment proves Newton wrong, you're saying. Now I'm saying Newton didn't say it very well. Okay, so that's my argument, that you cut the guy some slack. I mean, in some ways you shouldn't cut him any slack because he wrote the fucking thing in Latin, which was pretentious and elitist and nonsensical. So in some ways he should be misunderstood because it was own damn fault, because he didn't write the shit in English. All right, anyway. So you want to harp on about, just explain how doing your subtraction math, the difference, subtracting the differences out, I conserve the momentum. All right. So that should dispense with that. It's like the bowling pin argument. You can't get around the fact that you can only give the pins momentum, and you can't give the pins more momentum than you started with. It's not possible to give the pins more momentum. You should be able to agree with that. Alright, so then I made a point about one of the arguments in my energy live stream. Blah, blah, blah. Yeah, it wasn't a great argument. So I was changing the mass instead of the velocity. Okay, so this idiot, this green science guy, he's obsessing about some kind of grenade argument related to ballistics. And it's just so damn stupid. I don't care whether a grenade 20 feet away creates a piece of shrapnel that has the same velocity and weight as a bullet. That's not the subject, you moron. God damn. So let's do the, just for him, let's do it again. Where we just point out the imbecility of their theory, when it comes to just the simplest of experiments. So look, the argument is you're saying that one atom going 1,000 miles an hour is 1,000 times more capable of doing work than 1,000 atoms going 1 mile an hour. And now you can replace the atom with a horse, a buffalo, it doesn't matter what. You're saying that something with 1,000 times more velocity but 1,000 times less mass somehow does 1,000 times more work. And you have no evidence of that. Alright, so so the simple argument I've made is that you have guns and you're just going to, in one case, you're just going to shoot the 1,000 atoms, 1,000 atoms here, 1,000 atoms here, okay, and same explosive. Alright, and what you're going to get is 2 joules going this way and 2 joules going this way. Alright, now I do the experiment with a zip gun, okay, so now I just have the same explosive, just 2 bullets, but only 1 explosive. And what am I going to get? Well, I'm going to get the same result for the bullet, right? It's the same for both halves, and equal and opposite reaction for the momentum. So clearly I'm going to get a bullet with 2,000 joules going this way and a bullet going 2,000 joules this way by their theory. Now, the truth is it's just 2. So this was 2, and this is 2. This is 2 momentums and 2. And then the third experiment is obviously the gun, okay, and the bullet. And the simple truth is this is just 2. It's not 2,000, and this is 2. So momentum is perfectly rational, perfectly explains the circumstance. No defects, no mess. It's perfectly reasonable. It's the physics everybody believed, okay, because it makes perfectly good sense. You can say the same gunpowder produces exactly the same energy in all 3 experiments. By your theory, I made 4 joules here. I made 4,000 joules here, and I made 2,002 joules here. That's your theory. So which one of these is accurately defining how much energy is in the gunpowder? It has a different amount of energy depending on what kind of matter I put around it? Is that your argument? I mean, please explain to me how I test how much real joules the gunpowder has when I can get a different number by just putting a different mass, having it push a different mass. I can get any number I want. It's ridiculous. But I can't get any number I want if I go by a momentum. So I'm not even going to read his comment. I mean, he's just saying here, AI says power of a 36 bullet equivalent to power of non-energy of shrapnel from 12 hand grenades. What do you, yeah, what, 50 feet away? I could have a nuclear bomb take off 10 miles away, and I could put a little rock on a stick, and I might get hit with the rock at the same velocity as a bullet. So what? What does that have to do with this subject, you lunatic? Jeez. So we're going to get rid of this crap, because it's just crap. Oh, amazing. If I plug a lamp into the wall and I turn it on, I could have all the energy in the world. Well, you really can't, so that's silly. available to me, and I still won't emit light until I flip the switch. So what does that have to do with any of the subjects on this planet? I just don't even understand how you could take any of my videos and say I didn't say you had to turn on a light switch. I mean, just too fucking ridiculous. And get the power to the bulb. Power does work. Power, what do you think of the electrons moving are the only thing happening inside the wire, retard? That's it. You got electrons moving. There's nothing else happening in the wire. The electrons are moving. And they're being pushed by a force. That's it. God, he's so stupid. No volts and no amps. Yeah, no volts squared either for electricity. How come no volts squared? You know, a watt is a joule, you know. Why wouldn't you square the voltage? If you're going to bother squaring the velocity, why wouldn't you square the voltage? You've already fucked the science incredibly. You might as well fuck it all the way. Ugh, what an idiot. Alright. Let's see. Another 90-minute video only losers are going to watch. Oh, this is the blue moonshine guy. Blue, blue moon, alright. Blue ass moon. So, you know, it's such trite. You're just saying, why the fuck would somebody bother to do this? I mean, to just type this kind of crap on a video. I mean, what a waste of time. I mean, he really thinks I should go over to his videos and type this shit on his videos? You are a moron. Ha ha. LOL. Yeah. No, I'm not going to do that. Oh, God, what a fucking asshole. Let's see, I wish somebody more intelligent or at least very more honest would react to your videos. Yeah, it is very frustrating. Like I said, you can look at the Paul Nord. 2 weeks I spent with that asshole. And he just couldn't get the argument that springs don't push things equally. Unequal masses get unequal amounts of energy. I mean, I just went over it, and he was just too damn stupid. So let's do that one again. I mean, fuck this shit. So Hooke's law is great if you're compressing or expanding a spring and the mass is always attached to it. But as soon as you're detaching the mass from the spring, Hooke's law goes to hell. By the simple reason that you could understand, just like the ball bouncing, if I throw a tennis ball fast at the wall, it'll bounce off the wall and be really oscillating. I throw it slowly, it'll barely be oscillating. So, and the springs have the same problem. If I shoot a light mass at a high velocity, 50, let's just say velocity, and I have another heavy mass, and it's only going to go 10 velocity. Obviously, the spring has got to move the same speed as the object. You should be able to understand that. To maintain contact, it has to be going the same speed as the object. And when the object leaves at 50, the spring isn't going 0. The spring is going 49. So this spring is going 49 when the object leaves. This spring is only going 10 when the object leaves. That is, it doesn't go any faster. It can't hit the object because it's already going so slowly. So it has very little energy left in it because it's all the way down to 10. This one's still at 49. Okay, it's got a ton of energy still in it that it can't put in the object because the object's not in contact with the spring anymore. It already left. So clearly springs oscillate and wobble, and everybody should be able to know they've seen that. They've seen the experiment, and then the spring's going blah, 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 blah. You know, all the experiments have that. You know, if you can see the spring, like the Brozo ones especially, you know, when Brozo banged things in, you could see the spring going all crazy. So, I mean, that's a real problem because all that crazy crap the spring is doing is energy that didn't get into the object. That's energy lost. That's like friction. You've lost it. It's not part of the linear experiment anymore. Oh, what happened there? What the hell? It's all these random mouse hittings that I really have to try not to continue to do. All right. There's a yep comment here about stored energy, and yes, it's agreeing with me, so I won't bother. All right. So let's see. Forced reality. If anything, DraftScience proved that even supposed physicists can be stupid, liars, and dishonest. Yes. Well, whatever. It's obviously proven that they will not produce evidence. and credible evidence especially. So yeah, they'll just reference, they'll just keep doing what, PBS is, does pretty good researchers, right? And those researchers couldn't figure out that the Deschardelet experiment was physics garbage, denting the surface of clay. Because Brozo did the experiment where you put it all the way through, where you let it penetrate the clay, and guess what? It came out more like momentum and nothing like kinetic energy. So it was everything like twice the penetration, not 4 times the penetration. So again, more evidence on my side. Alright, and this asshole says, hey there, a long time fan of the channel. Oh, well, you're not really talking to me. I think there's some important things you should understand. Yeah, well, that sounds like fuck you material to me. So this is at whatever, these 2 weird names. Anyway, Gary has told us that an experiment disagrees with him. He won't accept it as evidence. So that's just a lie. Should I read any more of this crap? Why should I even read these lies? So when he asks for evidence, it's all show. Yeah, where's it all show? I'm sitting here looking for it. I'm willing to pay people to do the experiment. So there's no evidence that somebody offered to do an experiment and I wouldn't pay them. So have a credible person who has credible faculties to do the experiment. I mean, some sort of space and materials to do it correctly, and I'll pay to have the experiment done. You lying sack of shit. Oh, I shouldn't even read this. When he was shown videos where objects so it's just, he's just going to defend the dispar shit. So fuck off, you. I'm just. Liars are just liars. Fuck you. If you have to go on my channel and start lying about what I've said or what I've done, fuck you. I don't have to respond to lies. Ugh, God. It's just, humans are just such piles of dishonest pus. Okay. So, let's see. Somebody said something else. Indeed, I still think the physicist did a poor job, saying it's been proven without showing proof. Amazing. Yes, exactly. The more I watch your videos, the more I realize you don't know anything about physics. So this is a guy who posted 4 comments that are just this stupid. So, yes, guess what? Fuck off. Okay, so we'll remove that one. If there's no pull with gravity, there's no pull with anything. Anything. You're just too stupid to realize that you can't move anything with a magical, I'll just pull it. Pull, I'm pulling. Yeah, that doesn't work. There's just collisions. That's all you can do. You can collide with something. That's the only way you can interact with it. Okay, how do the small masses of the Cavendish experiment move? Yeah, well, it's obviously they're being pushed, moron. Okay, there's nothing pushing them. Yes, there is, jackass. That's called gravity, moron. Oh, God, too stupid. Let's see, 320. There's no pull, only push. Yes, I already said that on the same video you're responding to. You sound like an acolyte of ionic flat earther named Dell. Well, I don't care. You look like a pile of fucking steaming maggot-infested shit. Ugh. Cowboy blue thing. Yeah. Let's see. I've looked through a great many of your videos and I've seen where you demand others to do experiments. I demand experiments. I don't care who does them, and they have to be done well. But you haven't done one single experiment. So, see, this is another lie. Is that all you can do is lie? There's videos on my channel. They're showing me doing the experiment. I built an air track, for fuck's sake. So, fuck you. You're full of lies. I'm not going to read anymore. You're just a liar. Alright, so I will block him now. Alright, wow, you don't understand acceleration. That's all we need to know about you. Yes, that's exactly right. I don't understand how acceleration is squared. Yeah, I don't understand that. I think it's absolute fucking made up crap, you little blue shit. Alright, so enough of him. Waste of what's called valuable time. Alright, so I can science that made a response video. Yes, I have responded to it. I was going to write something formal. The tablet spoused out on me. Well, this is just not very interesting, so we'll just get rid of it because it's stupidly uninteresting. And this is Blue Moonshine again. Poor loser. So I should go on his video and just write poor loser. That'll be so impressive. I'll be making such a winning argument and showing how smart I am because I wrote poor loser. Oh, hilarious. What a piece of shit. Alright, we did the Veritasium slop and study revealed. So here he is again, the Val guy with a different account. A study revealed that 1 out of 3 pseudosciences is dumb as the other 2. Well, it's probably a sock account, I guess, because it has those little numbers after it. So I guess we'll just get rid of that. And that's it, I think. Oh, here's some more green science. Oh, it's the same bullet crap. I mean, just too stupid. So yeah, I'm just going to get rid of it because it doesn't have anything to do with the fucking subject. It's not evidence. It's not anything. It's just shit you're talking. You have to do something other than just talk shit. Oh, Christ, these people. He has a channel. Why don't you make a video, retard? I mean, I just drew some stuff here. Yeah, you can't see any of this, right? Because I didn't put it back on. Yeah, I didn't. So all this stuff is right here in front of you. Why don't you explain how I'm wrong? That springs do give all their energy back, no matter how small or light the object is that's on them. Yeah, because they don't. I mean, you can almost know this intuitively. Like the spring has a maximum speed. It can't move infinite speed. So you can sort of understand that its maximum speed means that, well, if I took a particle of dust, if I was going to get all the momentum into the dust, I'd have to make it go insanely fast. And we already know the spring can't go insanely fast. So there's no way it's going to push the piece of dust insanely fast, right? Because its maximum speed is probably 100. And to give all the momentum to the very light thing, it needs to go 500 or 700. And it can't go that fast. So obviously it can't get the energy into it. So there's so many ways to intuitively understand springs don't give back what they get. It's just a fact. They give back a lot more. The heavier the thing is, the more you'll get back. The lighter it is, the less you get back. Absolute fact. Physics ignores it. Just like they ignore that friction changes with velocity. Absolute fact, friction changes with velocity. How many times I can say it over and over again? How would that be? Friction changes with velocity. Friction changes with velocity. Friction changes with velocity. You don't weigh as much per inch the faster you go. That's why you can slide across thin ice. It's because you don't weigh as much when you go fast across the ice. Because gravity doesn't have time to make you weigh more. Yeah, gravity needs time to make you weigh your weight. That's why that's a per second force, is because it's time dependent. Can you understand the word? Time dependent. That's why it says 9.8 and it has a second underneath it. It's because it's time dependent. Oh, shall we just remove him? Yeah, we'll remove him, but we should just block him. The green guy has no hope of ever getting on the subject. Okay. Most adults are corrupt. Yes, by the way, showing emails is not me. Yes, well, the fact that there's troll accounts, I don't have much to do with, but yes, I did confuse your emails with the other asshole. Turned out to be an asshole. He seemed reasonable to start with, just like Paul Nord. I mean, they start off reasonable, and then as soon as they get nervous that they don't have any good answers, then they start getting belligerent. They start blaming me because they don't have any good answers to the questions. It's my fault they can't answer them. Alright, so I guess we'll take a break and see if there's something else I'd like to talk about later. and such. Yeah, that's what I'll do. See, maybe there'll be some more fascinating comments. Doubtful. Alright, we'll pause. Yeah, if we lose the video, who cares? Commenters. Not very useful. Alright, thought I would add a little bit, whoops, yeah, about projectile motion. Just as I thought about the a device you could buy to launch, ball bearings, big ones, whatever you call that. And, if you used it, you could, move it in this 90-degree kind of way, to simulate a cannon or, even straight up and down. And so I thought about that, and it just sort of illustrates some of the argument in the sense that when you're shooting horizontally, it's, 1 unit of velocity is half the distance of 2 units of velocity, because you're not really pulling any of the motion out. These would actually be, parabolas. And, the ground just ends the experiment, but it's always going to end it with this proportion of 1/2 the distance at 1 velocity versus 2 velocities. But as you move it up and start shooting it straight up, then you end up with this 4-to-1 thing happening. And obviously this 4-to-1 thing is a lot less distance than the actual linear distance that you could at 45 degrees reach, which might be 4 times the distance that you'll reach if you go straight up. So anyway, it just seemed like a good illustration of the fact that you're not doing any work in this example. And in this example, you are doing work against gravity, and that's where you get this huge disproportion. So again, it's just the same argument as the dropping argument, in the sense that you know that this is where 1 velocity happens. Okay. And it's 1 unit of time. So this experiment and this experiment are identical. And it's this part here, okay, that they're contending contains 3 units of work. So even though you're going really fast, they're claiming the gravity is taking 3 times your energy. Now it's only half your velocity, but it's 3 times your energy. So there's no evidence that these 2 parts of the experiment are any different. And so why would this part seem any different? It's just 1 unit of time. 1 unit of time, 1 unit of time. Alright, and it's only 2 units of total velocity that you started with. And so, like, the obvious argument is that, well, it's a time-dependent force. And so again, if you say 10 meters per second, and you just illustrated that as 10 hits you were going to get, let's just say 5 for the sake of the argument, 5 of them hit you every second. So in every second there's 5, and there's only 5 here. There's 5 here, and there's 5 here. And it makes perfectly good sense that you lost half your velocity to the 5 here, and you lost half your velocity to the 5 here. And because you're just moving slower. So it's the same argument that if it was sun, and it was going to suntan you, you get the same suntan here that you get here. In this second that you move the small amount of distance, you got just as many photons hit you as when you did this big distance. And you could say it's ball bearings that are hitting you, you could say it's sun, you could say it's water, you could say it's wind. It doesn't matter. I mean, the faster the force is going, the less there's any difference in terms of you moving through the force and getting closer to the light, so to speak. So I can't make the argument that if, with a light bulb just a foot or a meter away, I can't make the argument that I can move into the light bulb because it's not 9.8 meters per second anymore. It's not the same amount of photons hitting me here as here. But in this experiment, it's 9.8 through this whole distance. So you're never changing this rate. And that's all this is. You get hit 5 times here, and it takes away half your velocity. You get hit 5 times here, it takes away half your velocity. And you didn't do 4 times the work, you just did twice the work. It's perfectly illustrates also the rolling argument. If I was rolling these objects, you could, you'll get exactly the same outcome because the friction is changing. And if you thought of the friction as a paint sprayer, throwing paint at you, so you're going up, and the paint sprayer is going to push you, into a surface. You can understand that, yeah, that's the friction. And the faster I go through, the less paint per inch of distance hits me. And so the less pushing I do into the surface, and the slower I go, the more paint per square inch, per linear inch, and the more friction there is, the more I'm pushed. So you can make the argument with just crossing a stream. I mean, there's just so many ways to make the argument that, of course, it's about how long you're in the stream. And that's all that's going to matter. So if you're going slowly, the stream's going to drag you. You're going quickly, you're going to go right through it, and a much less stream is going to hit you because you're in it less time. So all these things that are moving some meters per second or moving miles per hour, all of those forces, anything doing that, is a time-dependent force. And it's about how much time you spend in the force, not how much distance you're in the force while it's the same time. So you get here the same time, but the fact is, and you might be exposed to more distance, but the distance isn't going to matter. It's just the time in the force. And that's all this is. The time in the force decides how much energy you lose. And the fact is, in 1 unit of time, you lose half your velocity, and the other unit of time, you lose the other half. So the velocities are equal. You lose them just as easily, and you're losing them to the same amount of force. So whatever their conception of how the geodesic works, it can't be proportional. Somehow it has to know that it's supposed to hit you with more stuff if you're going faster. And I don't think there's any mechanism that will allow it to know that it has to slow you down more when you're going faster. That you have to do 3 units of work here and just 1 unit of work there. It's just obviously just 2. That's all it has. It has 2 units of energy, because all it's going to do is 2 units of counter. There's only 2 units of counter force. There's only 2 units of gravity. So there can only be 2 units of energy you had in the beginning, because the 2 units of counter force stop you from moving. I just don't know how this isn't a convincing argument to reasonable people. That, yeah, there isn't really any evidence here that this is 4 times the work. Yeah, it's not 4 times the work. It doesn't take 4 times the work to go twice as fast. Going twice as fast doesn't produce 4 times the work. And again, the numbers get even more crazy. When you go to 3 times, and now you have to do 9 times the work. And then you go 4 times as fast, and it's 16 times the work. And then you end up with the the imbecility that bothers me the most, which is 25, times the fuel to make something go 5 times as fast. And I think everybody should know that doesn't happen in any real place in the universe. There's just no example of something requiring 25 times the fuel to spin 5 times as fast, or move 5 times as far, or to move 5 times as fast is the key word. 5 times as fast. Yeah. It's right here. I just, it's getting you to understand this part here, this 1/2 at 1/4 of the distance. It's just it's just screaming, that this is half your energy, this is half your energy, because they're both in the same units of time, which is perfectly consistent with the fact that you only got, if I drop you, you're only going to get 9.8 meters of velocity in this giant hunk of time, and you're only going to get 9.8 velocity in that 1 second of time. And that's what you're going to be going half the speed when I drop you here. Okay, and as I slow you down, you're going half your speed here, not in the middle, here. That lack of symmetry has to seem problematic to you, I would think. I just don't know how you make it make sense. 2 units of time, you got 2 units of velocity, and yet you think you did 4 units of work against gravity, or that you somehow will collect 4 units of gravitational energy when it was only 2 seconds. How could you have 4 units of the force when you were only in it 2 units of time? Alright, leave it there. Let's see if there's anything else I want to add to this video. It's just all very frustrating. See if there's any new comments. Yeah. Alright, superior mind. An ally of mine, let's call him. And so I'll read his comment. And so, just because he went to the trouble to write it, I should read it. I keep noticing they don't actually understand the actual workings of the systems they preach about. They just regurgitate. Some argue nobody understands the inner workings, which is odd once you see how simple it is. Well, yeah, it's sort of like no one understands quantum mechanics. Anybody who thinks they understand quantum mechanics doesn't understand quantum mechanics, that kind of jokey crap. And it's, but that's pretty pitiful, because the elemental universe is the simple verse, frankly, and it shouldn't be hard to understand. In that all the sum of units of momentum in various directions, in that it's all a sum of units of momentum in various directions. So yes, like the previous argument with the pool ball, it doesn't matter what direction something's traveling. You don't subtract momentum. There's no such thing as undoing motion by having some motion in another direction. Motions always have to be added as new motion in the universe. There's no such thing as undoing a motion. I've used the example. Okay, might as well draw it. I probably have room somewhere in here. So I used the pool ball example. I use another pool ball example, because you can just put 2 cue balls right next to each other. I mean, at a suitable distance. And if you're a good little pool shooter, you can shoot the cue ball right in between the 2 balls, and they'll both go sideways. And so what would the theory be? I've created 2 equal and opposite motions. Am I supposed to subtract them? I mean, the actual fact is that your total movement of this ball, say you hit it just right, and it pretty much absorbs all the energy of this ball, and it barely leaves, with a very tiny momentum. Then all the rest of the momentum will be going this way and that way. This total movement before and after will be the same. So the before total movement will, of mass and velocity will be the same as everything combined here, even though they're going in opposite directions. Everything combined here. And that's the absolute truth. And like I said, they're sort of arguing that Newton couldn't do that drawing. I don't know if Newton ever played billiards, so who knows. But it doesn't seem realistic to me to say Newton hadn't anticipated experiments that simple. That would prove there's no negative momentum or unmomentum. He certainly didn't use any words to indicate the idea of a momentum that is undoing something else's momentum. But he did talk a little bit like that when it comes to force. Again, an equal and opposite reaction can be interpreted to be the same as I have $10 and I give away $5. It would appear as an equal and opposite reaction in the sense that he's $5 richer and I'm $5 poorer. But it was only one action that causes that. There's not an equal and opposite reaction that made me $5 poorer. It was just the action of giving away the $5. All right. Let's see. Sum of all directions. That's all anything is when it comes down to it. They have various words which all mean the same thing for different contexts, and it's highly misleading. Well, I mean, obviously, stealing the word energy, to mean 1/2 mv squared, and just totally denying that momentum also causes motion is just sort of ridiculous. And to say that momentum can't be converted into the same units that you're going to measure for kinetic energy, when of course you can be. Let's see, some are confused and others are simply refused to acknowledge it, i.e. energy, force, momentum, etc., all made of the same single unit vectors of momentum. Yes, it is that simple. The whole universe is just a Planck amount of energy, you could argue. I guess I'll draw again. Yeah, okay. So, you could just say the force is this little, the stuff, cell phones, whatever. The radiation in the universe is all a bunch of these little vectors. And the fact is you can combine them into a big thing, and you could have, lots of those little vectors, and, like a school of fish. And even if some of the vectors were going this way and some were going that way, there's a net motion that's accomplished, and it's like Feynman says with the energy blocks, like as if energy was wooden blocks, and you have them, and the universe can scatter them, the universe can hide them, the universe can stack them, the universe can do lots of things with them, but it can't destroy them or make more of them. And so no matter what's using blocks to move, little arrows, the arrows move from object to object to object to object. And it's always the same number of little arrows in the universe. There's always the same amount of discrete force. So I've used an argument like a Sisyphus and a boulder. And there's a fixed number of boulders and there's a fixed number of Sisyphuses. And you can have 10 Sisyphuses pushing one boulder, or you can have a Sisyphus flying free in space. But they're always somewhere. They're either freely flying at the speed of light, or they're pushing an electron or a proton. And you can account, you can chart, you can watch, you can, what's the word for it? But you can account for everyone, every little bit of it. And that's what math is supposed to do. And the argument is MV as math, MV always has to equal MV. You always have to do conversions that end up with a big M, small v, and you end up with a big V and a small m. Or you end up with lots of little pieces, with various MVs, but they all have to add up to what you started with. You can't increase the amount of it, you can't decrease the amount of it. You can only transfer the energy. And again, this is a 400-year-old Descartesian concept. Other people said it before Descartes, but he was the one who said it the loudest. The first to say it loudly, let's say. Alright, it's all made of the same thing, little vectors of AK single force units. Okay. Exponents should make it obvious. They assume evidence because somebody else said there's lots of evidence or application. Well, there's a difference between the physicists and the follow-alongers who just believe or are interested subtly. Even I can science that guy, right? He's a college-educated physicist, but you got to wonder about his education, because he doesn't know who Leibniz is, doesn't know who Charolais is, doesn't know a lot of stuff. And that's a little spooky. Okay. You got to wonder what kind of science education he had. They assume evidence because somebody else said there's lots of... but there isn't. They just assume. Sort of the argumentum ad populum fallacy. Just bad logic. Evidence doesn't show what they claim. Well, the fact is the fact that there's so little evidence for any of these elemental experiments, that they haven't tested any of this. Again, the one that seems so logical to me, the one that you just say, oh wow, if I was really going to study energy, and especially gravity, I'd be damn curious about this one. What speed do I have to crash something into the scale to make its impulse weight equal gravity? That's hugely interesting. And what I calculate it to be is 1 mile an hour. And what I also calculate is that it's 1 centimeter is 1 mile an hour. And so if you want to double your weight in gravity, 1 centimeter is essentially the same 1 mile an hour. Yeah. Says a lot. Demonstrating that your net momentum into the earth is 1 mile an hour. Alright. 1 mile an hour times your weight. Okay. I notice most of these characters spend a lot of words focusing only on why you should believe rather than this is how we know. Well, that's the key thing, right? I keep asking them, what convinced you? What experiment convinced you? What experiment convinced you? And I never get any answers to that, because apparently it's not about being convinced by evidence. And again, I've used the lawyer example of an evidence table. And, you know, what convinces you at a trial? Well, DNA evidence and fingerprints, you know, that's what convinces you. Ballistic tests, you know, this kind of stuff, and they don't have any of that. All right. With a demonstration. Often we see now real science is not being practiced anymore. It's all show and display, so they all have boxed experiments. I was really surprised to find out that Professor Lewin didn't invent the experiments he does, right? It seems like he was being creative, and he created this little monkey thing, and it falls, and he shoots it, and you thought that he figured out how to do this teaching thing with this demonstration, and you can find all of that videoed in the 60s. I mean, it was already done by MIT scientists, and it's just, you know, almost every single one of his experiments was done by some other physics professor in exactly the same way, which is really lame, frankly. That he's sort of implying that this is his performance art, and he really did just steal it from other people. Often we see now real science is not being produced anymore. Science is supposed to embrace scrutiny, not dismiss inquiries as internet disinfo. I don't even think they do that. They call it flat earth and pseudoscience. I think he should actually argue logically, demonstrate, provide evidence, experiments to verify or get out, but instead excuses, avoidance, etc. So this is about some moron, I guess, who made some comments. Exponent. I think this is he's emailed me, he's the idiot with the bullets, you know, talking about grenades and bullets being the same thing, when he's just talking about a projectile and a velocity. And, you know, that's not the subject. We don't really we almost don't care how you create a projectile with velocity. We care about what fuel you use to do it. So anyway. Oh, at least it's a new comment. Yeah, so it's something. Let's see, this blobia, whatever, made some sort of response comment. Let's see what it says. Alright, you're effectively arguing that Newton increased the quantity of motion in the system and didn't notice. That's my accusation, that their reading of Newton, saying that Newton believed in the creation of free momentum. No, he said quantity of motion does not change. I know, but the experiment itself doesn't do that. The experiment itself creates more momentum in the same direction. And that's what I'm saying is that would be obvious to anybody that if you're increasing the momentum and you didn't add any new energy, that's automatically free momentum. And the scientists of the time were rather obsessed with trying, from the mid 1600s to the mid 1700s, there was an awful lot of people searching for perpetual motion. They thought it was something realistically graspable, and that free energy, of course. So I think it's on your part just being disingenuous to say that Newton couldn't observe that he's made more momentum in a direction. Because going that way doesn't change anything. I mean, the stuff going that way doesn't interfere with the stuff going this way. I have more momentum this way, which means I can do the same experiment again and have even more momentum. And I can do the same experiment again and have even more momentum. I'm sure Newton didn't think that was possible. So you can imply that he didn't notice he was defending a free momentum experiment, but I think he would have noticed that. That's my argument. So you can say you don't agree, that's fine, but I don't think you have any evidence countering that it's, I think, logically impossible that Newton believed you could increase momentum in a direction and that wasn't free energy. No, he said quantity. The quantity does not change. Well, it obviously is changing. You're making more in this direction. You're somehow saying that you canceled it because something went that way. And obviously you can't cancel energy. But see how he defined the quantity. It's the same as momentum in modern physics. Well, there's no point in saying this. This isn't about mv squared. This argument is about whether you can have plus and minus. All right, so it only relates to mv squared in the sense that this is a way they pretend that they're conserving both kinetic energy and momentum, is because they're doing this subtracting when they feel like it with momentum, and then they're adding when it's kinetic energy. So obviously you're going to get very different numbers. But I just mean it's just a shenanigan. All right, let's see. It's the same as momentum in modern physics. I'm not going to argue with you. It's free momentum. That's what it is. It's free momentum in the same direction. That's an experiment that can only lead to free energy. Isn't that funny? Question mark. Well, again, I don't think it's funny, and I don't really see. Again, your argument is that the not perfect grammar or literacy or verbiage of Newton, you'll interpret it one way, and I'm going to have to interpret it another way because I just don't see how Isaac Newton could have possibly believed. Now, there's this little sentence right in the middle of that, the paragraph he didn't publish, where he says, "If I may say," or if I may say. I think those are the exact words. So he was obviously saying something about what I'm saying now sounds kind of crazy. If I may say so. Yeah, that's what he said. If I may say so. So there's, you have to wonder, why would he say that if this was just an absolute fact? Why would he say, if I may say, so say? If I may so say. That's the exact quote. That's a rather weird phrase to stick in the middle of a statement about it. So he's obviously saying, yes, something I'm saying is a little queer. Or weird. The quantity of motion as you define it can change. So again, it can't. So that's an absolute lie. I mean, why bother lying? It doesn't change because I don't believe in plus energy and minus energy. I don't believe in unenergy and real energy. I don't believe in energy and anti-energy. So fuck you. It's a bullshit accusation. But that's your problem. No, that's your problem, fucker. Your definition is not the Newtonian definition. Well, yes, it is. So you can keep saying it isn't, but Newton clearly said twice the force, twice the motion, 3 times the force, 3 times the motion. So we know he wasn't a Leibnizian. All kinds of explosives prove energy left does not undo energy right. So that one's pretty clear. Let's see what he says, right? Do you think he's going to say something? I think it's going to be like 2 words or something. Oh, no, it isn't. Okay. Newton wasn't talking about energy. So, fuck you. I mean, it's just so amazing. They didn't have the word energy, but I'm sure Galileo, Newton, and Descartes were all talking about quantity of motion as if it was energy. So this is just baby talk. They obviously didn't believe in v squared. That's the absolute truth. And they thought the universe was pretty tight, pretty conservational. Descartes especially, right? You can't say that Descartes invented arguments about conservation of energy when Descartes couldn't have made it any simpler. He said basically God started it and it'll run all by itself, and God never has to interfere because the energy is always going from one place to another and it never runs out. So, I mean, Descartes was the one who really pushed the idea of conservation of energy in the universe. And for you to say Descartes didn't think quantity of motion was energy is just playing fucking word games. It's just such a little petty weaselly tactic. All right, you're claiming you can have okay, so you went an electric car crash where 200 momentums go in and only 100 comes out. So that's quoting me. How is that conservation of momentum? So that's the question I asked. Seems pretty reasonable, right? I mean, obviously you can't conserve the momentum if I have more MV after than I started with. And the fact is, I mean, less MV than I started with. All right. So he says, you get that 200, you add the motions going in opposite directions together. If you do like Newton told us to do, so again, Newton didn't tell you to, but whatever, you get 100 before and 100 after. No, you know there's actual motion in the universe. You can't deny the motion of both objects. So are you really saying that Newton said the energy in a collision you don't add? When of course you have to add it. The huge difference is the one where the two things don't move. So if I crash two things into each other elastically, I get back all the motion I started with. But if they hit each other and they cause all kinds of heat and deformation, we already know that's going to have to conserve both of their energies. It's not going to be 50 in, and only 25 out. That's not going to happen. It's going to be 50 units of heat. I mean 100 units of heat. If it's 50 and 50, I have to make 100 units of heat. I can't make 50 units of heat. So again, you're just talking around the subject. Such bullshit. All right. So let's see if somebody else said anything to anything else here. Blah 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 blah. Nonsense, nonsense, blah blah blah, nonsense. Okay, nothing else. All right, let me check. Let's check, see if there's a. So the guy did email me the deGrasse Tyson link, but it's one of these popular channels that I don't know why they're even popular. Some moron who interviews people, and it's all clickbaity, and it's all jump cuts, and it's all text flying on there, and it's and it's just, why the fuck would I bother with any of that shit? So sorry. Yeah, I don't see the point doing a response video to it. And most of the video is about him saying the world's going to hell. It's not even a physics video. All right. See what we got. Oh, so this equinox shadow guy. Yeah. So I told him I'm not interested. Just send me some. All I care about is evidence. So I said I'm not interested in unevidenced gibberish. Link to a credible experiments or fuck off. And he said to me, "Yep, confirmed. You are mad, insane, and a lunatic." Oh, because I'm not going to be convinced by gibberish. Oh, okay. You will never become anything real in the scientific physics world. Well, I already know that's not true because I already know that I have a model that works so much better. I mean, 1,000,000 times less complicated, and it works better. It's not only cheaper, it's so much better. All right. Yeah, so that probably is enough. I guess I'll take one more pause and see if there's anything else I can. Well, it's probably enough. Yeah, half hour plus whatever I did before, so that should be plenty. Alrighty then, so till the next time and such, it's just this, ongoing battle to get people to actually deal with arguments and explain, should I subtract this motion from this motion by Newton's own words? Motion in counter directions, that's what it is. It's motion in opposite directions, so I should subtract it, right? So how did I conserve the momentum? If I have zero momentum when we're done, how did I conserve what I put in? Yeah, I don't think so. Okay, anyway. Till the next time and such and so forth and whatnot.